If you manage a network, you have likely spent time at a command line interface, repeatedly hitting the up arrow to run pings. It is a tedious way to hunt down an intermittent connectivity drop. Cisco IP SLA offers a cleaner approach. It is a built-in tool that runs in the background of your router, automatically running those connectivity tests and logging the results for you. To set this up, you only need two things: command line access to a Cisco router in privileged exec mode, and the target IP address you want to monitor. Relying on manual pings means you are constantly reacting to user complaints. Automating the process allows you to capture network drops exactly when they happen, providing the data you need before the problem escalates. Step 1 is always establishing a baseline. From your router CLI, execute a standard manual ping to your target destination. You are looking for a string of exclamation points. In the Cisco iOS environment, these indicate successful replies from the destination device. This manual test confirms the path is up right now. However, it gives us zero visibility into the health of the network 5 minutes from now. This diagram shows how IP SLA solves that blind spot. Instead of a one-off test, the HQ router acts as a persistent agent, continuously sending ICMP echo requests and collecting the replies from the branch router over time. Doing that initial manual ping proves the route actually exists. Because we verified the baseline first, if our automated SLA test fails later, we know it is a genuine network drop and not a simple misconfiguration or blocked port. Enter Global Configuration Mode on your router and type IP SLA 1. This creates our new monitoring process and assigns it Operation ID 1. Next, tell the router what test to run by typing ICMP echo, followed by our target IP, 10.10.3.3. Set the frequency to 10. This instructs the router to send a ping every 10 seconds, generating a dense stream of data to review. If you are setting this up in a live production environment, the default frequency of 60 seconds is usually sufficient to track routing problems without adding unnecessary traffic to your links. Exit back to Global Configuration Mode to schedule the test. We have built the operation, but now we must explicitly tell the router when to start it and how long to let it run. Type IP SLA Schedule 1. Adding the parameter Life Forever tells the process to run indefinitely, and Start Time Now boots up the test immediately. Keep this operational rule in mind. The moment you press Enter on that schedule command, the IP SLA configuration is locked. You cannot modify the target IP or the frequency after this point without deleting the entire operation and starting over. Locking the parameters prevents accidental edits to the test criteria. This ensures the historical performance data you collect over the coming days remains consistent and statistically valid. Now that the test is running, step back to privileged exec mode to check our work. Run Show IP SLA Configuration and check the bottom of the output block. Finding the word Active confirms your background process has initialized. To see the actual performance data, run Show IP SLA Statistics. The return code will say OK if the target responds. Right beneath that, compare the number of successes directly against the number of failures to quantify how reliable the path has been. You have successfully offloaded a manual task. The router is now continuously monitoring hardware availability around the clock, completely independent of your terminal session. If a department reports that a remote application dropped offline at 3 a.m., you no longer have to guess what happened while you were asleep. You can simply check the IP SLA failure counters the next morning to verify exactly how many test packets were lost during that window. Once you are comfortable with basic ICMP testing, you can return to the configuration menu to deploy more complex IP SLA operations, like tracking voice jitter or measuring precise network latency. Automating connectivity checks provides an objective, permanent record of your network's uptime. It replaces guesswork and assumptions with concrete statistics, giving you the exact data required to isolate issues and successfully repair them.